Hi everyone, this is Mr. M here, just going through an example of how to graph a rational function. So I'll try and go through all the steps here, and these are all the steps that you need to go through when graphing any rational function. So the first step is to factor. So this one being a quadratic, I encourage you to pause the video and factor the numerator and factor the denominator, and you will get f of x equals x minus 4 times x plus 1 on top, and the denominator in the bottom you get x minus 1 and x plus 3. So if you're unsure of how I factored that, pause it, try the factoring, it's sum and product for both. You should be able to get the factors. Once I get the factored version, what I can do is I can next look at the denominator. So the denominator here will tell me what my vertical asymptotes will be. So the second thing, list my vertical asymptotes. And I know from the denominator that I'm going to have a restriction at x equals 1. So that tells me that I'm going to have a vertical asymptote at x equals 1. I'm also going to have a restriction at x equals negative 3. So I'm going to have a vertical asymptote at x equals negative 3. Okay, I'm going to go over here and plot these right away so I don't forget. There's negative 3. We have more than I need here, and positive 1. I don't need a grid that big. There's my vertical asymptotes. Dashed lines, I'm going to label them. So this one's x equals 1, x equals negative 3. So that's step 2, vertical asymptotes. And they come from, color code this, vertical asymptotes come from the denominator. So restrictions on the denominator will give you vertical asymptotes. Okay, next I'm going to look at my horizontal asymptote. So that's step 3. Horizontal asymptote for this one would be 1. Where I get the 1 from is I look at the numerator and note the denominator. It's probably easier to look at the unfactored form. I look at the shortcut here would be look at the highest degree on the top, which is x squared, the highest degree on the bottom, which is x squared, and I just divide. What's 1x squared divided by 1x squared? It should give me y equals 1 as my horizontal asymptote. And that'll come out later too when we set up our chart. Okay, so there's y equals 1 as our horizontal asymptote. I'll draw that in right now so don't forget. Try and do a dashed line. It's hard to do with marker, by the way, if you're trying it with marker. Okay, there's my horizontal asymptote. I guess I should have made that in black, but that's okay. Y equals 1. Next step, step 4. I'm going to look at the x-intercepts. And how I find the x-intercepts is I look at, probably the factored form is easier, and I let y equals 0. So I'm going to have 0 equals x minus 4, x plus 1, all over, x minus 1, x plus 3. So what I do to solve this is I need to multiply, I need to get rid of the denominator, so I have to multiply both sides by this whole big long denominator. And I'm going to multiply it by 0, so 0 times that whole big denominator will give me 0. So I'm really just left with the numerator here. And when I write just the numerator equals 1, or equals 0, sorry, that's like solving a quadratic. So when I go to solve this, I'm going to have roots of x equals 4 and x equals negative 1. Those are my x-intercepts, which I will now plot. So x equals 4, negative 1 here. X equals 4, 1, 2, 3, 4, and x equals negative 1 there. Okay, so that's step 4, x-intercepts. Step 5, graph the y. I need to figure out the y-intercept, or the y-intercept. I guess it wouldn't be more than 1 because then it wouldn't be a function. So for this, I let x equal 0. So I work out f at 0. Might be easier to go back to the original equation, because if you're doing with f at 0, really you're just, the x's will all be 0, so you're left with just the constants. So negative 4 over negative 3. So I'll show the work here. But 0 squared minus 3 times 0 minus 4 all over 0 squared plus 2 times 0 minus 3. So where all the x's were are all 0, so that's nothing. So really I'm just left with negative 4 over 3, which gives me 4/3. Or it might be easier for graphing to think about it as 1 and a third. So I'll graph that. Get my color coding here. Green for the Fighting Irish. So 1 and a third would be a little bit more than 1, about a third of the way up to 2, so about there. Okay. Last step. I need to figure out, I'm going to set up a table and figure out what's happening near the asymptotes. So I guess I'll just write it about here. Step 6. As x approaches, y approaches. So as x approaches, I need to check both sides of my asymptotes. So I need to check negative 3, a little bit less than negative 3. Negative 3, a little bit more than negative 3. A little bit less than 1. A little bit more than 1. And I also need to check to see what's happening for the asymptotes. Is it going to be more than 1 or less than 1? So I'm going to check negative infinity and positive infinity. So I think the best way to do this is to use test points. Now in class, a lot of people are getting hung up on less than negative 3, especially when it was a negative. The positive values people were fine with, but I think just to give you an example here, a test point for negative 3, like a little bit less than negative 3 or negative 3 from the left hand side, I would probably use a test point of negative 3.01 or negative 3.001. I'm not even sure you can see that, but that would give me a number that's a little bit less than negative 3. And if I work that out, I'm pretty sure I'm going to get negative infinity here. And then a test point for a number that's a little bit more than negative 3, so think of the number line, would be negative 2.99. And if I work that out, I'm going to get positive. Oh, did I make a mistake here? Negative. This should be negative infinity. Sorry, the first one's to positive infinity. That one's negative infinity. And then do the same thing for 1 and negative 1, and you will get positive infinity here and negative infinity there. When you look for the horizontal asymptote, you pick numbers you can use test points like negative 1,000 or 1,000 should be good enough. If you use that test point for negative infinity, you'll get 1, but it's going to be a little bit more than 1 and a little bit less than 1 there. So now that I'm pretty confident my table is right, I'm going to go to my graph. I'm going to draw my endpoints here, or what's happening near the endpoints here, near the asymptotes. So negative 3, a little bit less than negative 3 would be on this side, and it's going to positive infinity, so I'm going to have, it's going to go up like, so there's my arrow there, it's going to go up to infinity there. A little bit more than negative 3, it's going to go down to negative infinity, so that's going to be a negative infinity. A little bit less than 1 goes to positive infinity, so this is going to be positive infinity. A little bit more than 1 is going to be negative infinity, so that's there. Negative infinity will be over on this side, and it's going to be 1 but a little bit more than 1, so it's going to come in on this side of the asymptote. And positive infinity is a little bit less than 1, so it's going to come on this side of the asymptote. And once you've got that, just connect the arrows and you should be good. So there's 1. Make sure I go through my X-intercept and my y-intercept. There's 2. And I'll show you my X-intercept here. There's 3. And that's the graph with all the steps. So these are the steps you always want to go through. Factor it if it needs to. Find the vertical asymptote, the horizontal asymptote, the x and y-intercepts, and then you figure out what's happening near the asymptotes, both vertical and horizontal. Okay, I hope that helps. Pause it, rewind it, do what you need to do. Good luck.